The next one here is looking at some of the grout materials. So here we opted for the TLS. This is one we've worked with some groups that have specifically doing their testing around the ASTM D5334 standard. This is a great option for these types of samples. The probe is inserted directly into that mix. You do not need a rigid sample geometry like again, slurries, non-solids. There's actually applications not related to this webinar here today, but for like polymer melts, for other applications, the TLS is certainly a great option there. And it's completely encased in stainless steel, so it's nice and robust to deal with some of these material types. The same sample or the same method here could also be applied to the soils, to those aggregate cuttings as well. So very versatile, especially for the geological material applications. So what we actually did here, we took a neat grout matrix, measured that just at room temperature, ambient conditions. But then we actually kind of formulated an example here where we added a 10% by weight conductive filler into the mix. I mixed that all up and then retested that sample. And we showed just doing something very simple like this, we saw about an 18% shift in the thermal conductivity. When you look at thermal conductivity of many like commercial grade thermal grouts, these can be in excess of 1.5 or even 2.5 watts per meter Kelvin. Again, where you may have some of those very specialized binders and additives. But, from this example here, it really just illustrates the point that, fillers are a big part of what are driving the performance. Again, the other constituent parts also play a role, but, when you're looking at conductive fillers being, their own separate, I'll call it ingredient in the recipe, what type of filler you choose, how much of it you're adding, these can directly impact that heat exchanging performance that is observed.